All right, so let's talk about some of the math elements that we have to worry about. So we've got the multipliers. Let's talk a little bit about money multiplier first of all. Actually, no, let's talk about spending multiplier. Okay, remember that stuff, the MPC and the MPS? Yeah. All right. MPC, what does that stand for?
Consumption.
Most privileged cockatiel. Marginal propensity to consume. MPC is the marginal propensity to consume. Okay, that's fancy speak for saying how much do you spend out of additional money that you get. Okay, so if you were given additional money, how much do you spend out of that? Okay, so it's a percentage, yeah, but we express it as a decimal. So the example is I give you $10,000. If you spend $9,000 out of the 10,000, then what was your MPC? 0.9, right? You spend 9,000 out of the 10,000, that's 90% or 0.9. Okay, so your marginal propensity to consume is 0.9. If you had spent 8,000, it'd be 0.8. If you had spent 7,000, it'd be 0.7, etc. Okay. Now, what that also means is that any of the money that you did not spend, what did you do with it?
Save.
You saved it, right? You can only spend or save your money. If you don't spend it, you were therefore saving it. So if you spent 9,000 of it, you therefore saved 1,000 of it. So what would your marginal propensity to save be? 0.1, right? MPC and MPS have to equal 1. We're not doing one or doing the other. So once you figured out the MPC, you therefore know the MPS, right? So it's 9,000 of additional 10,000, MPC of 0.9, MPS is 0.1. Okay, and when they give you these problems, they'll say like, oh, so-and-so, they save a certain percentage of my additional money they get, right? Or they'll just give you the MPC, or occasionally they'll do that thing where I've done that a couple of times where they give you a chart, right? Where it'll show you the change in income and the change in consumption. You know what I'm talking about? Okay. So what they're asking you to do there is to figure out, okay, so at each step, how much did income change by, and how much did consumption change by? All right. Well, if at each step income is changing by 10,000, each step consumption is changing by 9,000, well, then you know the MPC is 0.9, right? So when we figure out the MPC and the MPS, what that enables us to do is to figure out the multipliers, both the spending multiplier and the tax multiplier. Okay. We use the spending multiplier when there's a change in spending. All right. Any sort of change in spending. So when we're talking about spending here, we're talking about the old equation there, C plus IG plus G plus XN. Right? If we have a change in spending in any one of those categories, we can apply the spending multiplier. Okay? And when they're wanting you to use this, they'll say, oh, there was a change of this much in consumption, or a change of this much in investment, or a change in this much of government spending or net exports. All right? So there was a change of this much, and then what they want to know is what is the overall change in aggregate demand or GDP, right? They'll say one or the other. Because remember is that when we change spending in any one of these, there's an even bigger change in overall aggregate demand or GDP, okay? Because a little bit of change in spending here creates a bigger overall change in spending. So this goes back to the example we've used before. Let's say the government spends a whole lot of money paying people to do something. Let's say it increases spending by, $1 billion. Okay, so when it spent $1 billion to pay people to do something, that itself was GDP. And then somebody else has the $1 billion now. What are they going to do?
Spend it.
Spend it, right? But they won't spend all of it. They'll spend a chunk of it. Let's say they spend 9% of it. Well, when they spent 9% of it, in this case, that'd be $900 million. That was an additional $900 million in GDP, right? Slash aggregate demand. Okay, and now somebody else has that $900 million. And what will they do? Spend it. Spend 90% of it, right? Which will then be additional GDP, right? So the idea is there's a multiplier effect. You have a little bit of spending here, and it creates an even larger change in spending down here. Okay? So what we're trying to figure out then is based upon this small change in spending there, the initial change, what is going to be the overall big change, right? So in order to do that, we need the MPC and the MPS. Okay? So I'll give you a question to figure out one or the other. So we've got the two multipliers, the spending multiplier and the tax multiplier. Use the spending multiplier when there's a change in spending. Again, C or IG or G or XN. Okay, and the equation for that is spending multiplier is equal to, you better remember,
It's 1 over MPC, right?
MPS.
I was about to say empty.
Yeah, 1 over MPS. MPS is always the one the denominator. Okay, 1 over MPS. Right? And then you have the tax multiplier. And we use the tax multiplier if we're talking about a change in taxes. That's equal to what?
1 over MPC.
Negative 1.
Negative MPC over MPS.
Wait, it was a change in what though? Tax.
Change in taxes.
Okay.
This is a change in spending. All right, it doesn't have to be government spending. It could be, again, consumption or investment or net exports. All right, we use the tax multiplier when we're talking about a change in taxes. That the government is increasing or decreasing. Okay? Now, in both these cases, the multiplier will be positive if we're going to create more spending. Okay, if we create more spending, the multiplier is going to be positive. So if we increase spending, positive. If we were going to decrease spending, the multiplier would be negative. Okay, and then down here with the tax multiplier, if we increase taxes, it's going to be negative, because if we increase taxes, people don't have as much money to spend, so we won't have as much spending. But if we were to lower taxes, the multiplier would be positive, because if we lower the multiplier, or excuse me, if we lower taxes, that means that people have more money to spend. Okay? So if it's going to be positive or negative, you just want to look at, are we increasing or decreasing the amount of spending that will take place in the economy? Okay? So in our scenario here, if we say the MPC is 0.9 and the MPS is therefore 0.1, the spending multiplier would be 1 over 0.1, which gives you a multiplier of 10. All right, the tax multiplier would be a negative 0.9 over 0.1, which would give you a tax multiplier of 0.9. Okay? And the way we use these is you see a problem, and the problem says something like, okay, the government increases spending by $1 billion. Okay? What will be the overall change in aggregate demand, GDP? Okay, so if the government increases spending by $1 billion, what are we going to use? The spending multiplier or the tax multiplier? Spending multiplier. Okay? Use the spending multiplier, which in our scenario here, we already figured out is going to be 10. We multiply that by that change in spending, which was $1 billion. So that equals 10 times 1,
10
$10 billion. So the change in spending was $10 billion. Okay, overall change in spending in aggregate demand / GDP. And then it might give you a question that'll be like, okay, well, the government, this is the balanced budget idea, right? So the government increases spending by $1 billion. Or excuse me, not increases spending, increases taxes by $1 billion.
Well, it's a tax
Okay?
multiplier.
Yeah, so we're going to use the tax multipliers to talk about taxes. We establish here the tax multiplier is -9. We multiply that by the change in taxes. And it's a negative because we're increasing taxes, right? 1 billion, so that would give us a decrease in aggregate demand of $9 billion. Oh, by the way, when I'm writing on the board here, I'm using B. If you were to get something like this in Alpha Q, write out billion. Alright. They'd probably take the shorthand, but just putting the B there, but don't make assumptions. When doing the FRQs and putting in your answers, don't make assumptions. Okay, make sure you put the dollar sign, make sure you write out the billion, or actually put the entire zeros there if you really feel like it. All right. Now, let's say that we did both at the same time, right? This is the balanced budget idea. The government increased spending by $1 billion, and then it increased taxes by $1 billion in order to pay for it. Well, what would be the change in GDP? Well, the increased spending changed aggregate demand by a positive 10 billion, and the increased taxes changed GDP by negative 9 billion. So what was the final result?
1 billion?
Yeah, 1 billion. Okay. This goes back to the idea, remember, that if we change both taxes and spending by equal amounts, the change is going to be whatever the change in spending was. Okay? So if you increase taxes by $1 billion and you increase spending by $1 billion, the end change in GDP will be that 1 billion. Okay? And the reason for this is the multiplier is always going to wind up being, spending multiplier will always wind up being 1 larger than what the tax multiplier is. Okay? Good so far? Okay? And it's possible they might give you a question where they go from the opposite direction, right? So they'll give you the MPC and the MPS, and they'll give you what is the overall change in GDP, right? Where they could say, oh, well, the change in GDP was $10 billion. Okay? If the MPC is 0.9, the MPS is 0.1, and the overall change in GDP was 10 billion, what was the change in government spending in order to be able to accomplish that? Right? So it's the same problem, you're just working in reverse at this point. But it's really just solving for x, right? You're starting from 10 billion, or 10 billion over there, realizing you have to divide by 10 in order to get to a change of 1 billion. All right, another variation of this is that it'll have a change of 10 billion, and then it'll ask you something like how much would the government have to change taxes in order to get the same GDP change, right? So you have to figure out the 10 billion and how much it'd have to be on the tax multiplier in order to be able to change it. Okay. Now the MPC and the MPS, I've mentioned this before, but they like to keep the math easy since you don't get to use calculator, and you're going to have a rather isolated set of MPCs and MPSs that you wind up having to face, which means you also have a limited set of multipliers. All right. Okay, so the MPCs you'll see are 0.9 and 0.1, 0.8, 0.2, 0.75, 0.25, and you might see 2/3, 1/3. It's a little bit more unusual, but it'll happen. All right. And the reason they use these is because they make multipliers really easy. Okay. So you get 10 and -9, you would get 5, right? Yeah, right. 5 and -4, 4, -3, 3, -2. Right, these are typically the only sets you're going to wind up seeing for MPC, MPS. They're not going to give you an MPC of like, oh, a country has an MPC of 0.739 or something like that. That'd be a nightmare to have to try to figure out the multipliers when you don't wind up having a calculator. So they'll use these because they make the math nice and simple. Okay, questions so far? Anything? All right. Is everybody good? Can I erase this? All right. No, don't power off. You're gonna do anything. Fine, you do that. Okay, so we got this, and then we also got the money multiplier, right? So this has to do with the whole balance sheets and stuff like this. When the Fed is going to be engaging in monetary policy, then the money multiplier applies. Okay? And so this goes back to the whole required reserve ratio and stuff like that. Okay? So, let's say there's a required reserve ratio of 20%. So there's a required reserve ratio of 20%, and that means what does the bank have to do?
They have to save 20%.
Okay, any money that's deposited in the bank has to keep a hold of 20% of that as required reserves, which means what happens to the rest of it?
Loaned out or
Okay, it becomes excess reserves, and what can they do with that money?
And then-
Not spend it, loan it out.
there you go, step ahead.
Okay, that's what the bank does with the money, is it loans it out, right? Not spending it when it gets deposited. So required reserves is what they have to keep on hand, and excess reserves is what they are allowed to loan out. Okay, allowed to loan out, not yet have loaned out. Now the idea with the money multiplier is that when people deposit money into the bank and the bank loans out money, it creates brand new money in the money supply that did not exist previously. Okay. So this is where we go through that cycle, right? And we had talked about this in a previous review, I think, review number 1, where you deposit money in the bank loans the money out and creates new money, and it's a cycle, right? Remember how we're making an assumption that all the money is getting loaned out and all the money is getting redeposited? Okay, 2 assumptions in the cycle: all the excess reserves getting loaned out and all the money is getting redeposited back in the banking system. Okay, I want to emphasize that because if one of those assumptions fail to hold, we will not produce the maximum that we could create. So the money multiplier is a way to see how much money we get created once that cycle plays itself all the way out. Okay, so the money multiplier is equal to what? 1 over what? R. Required reserve ratio. Right, in this case it'd be 1 over 20%, which is 0.2, which gives you a multiplier of 5. Okay, in order to find the maximum amount of money that's going to get created, you take the money multiplier times the initial excess reserves amount, right? Whatever the initial excess reserves amount is. So if this is our scenario here, let's say somebody comes along and deposits $10,000 in their bank account. Well, if that's the case, and there's a 20% required reserve ratio, how much does the bank have to keep as required reserves? Huh? What's 20% of 10,000? 2,000. So you had required reserves of 2,000, which means how much was there in excess reserves? 8,000, the rest of it. So this is your initial excess reserves amount. You take the 8,000 times our money multiplier of 5, and that gives you 8,000 times 5. 40,000. So the money supply could increase by a maximum of $40,000. Again, this is a maximum possible amount. Doesn't mean it actually does increase by 40,000, just a maximum amount of 40,000. Okay? Now, when you get these questions, you've got to pay careful attention to making sure they're answering what it is that it's asking for. So if it's asking about the money supply, okay, that increases by 40,000. Let's say that it's asking when Joe deposits this money into his bank account, how much did demand deposits increase by throughout the banking system?
That would just be the amount he deposited.
Well, throughout the banking system. Remember, this 40,000 that's getting created when banks loan out the money, we're assuming all of that is getting redeposited into the banking system, right? So demand deposits increased by this, right? But if it's talking about how much did they increase because of his deposit, we also have to include the original one. Okay, if we just said 40,000, we would get it wrong because we'd be missing out on the original deposit. So how much did they increase by throughout the banking system? The answer would be 50,000. Okay. This money that's getting created is getting redeposited into the banking system, plus the original $10,000 deposit, right? So therefore, demand deposits have increased by 50,000. Okay. Sometimes they'll throw the little loop, or maybe they'll just ask about, oh, how much can this one bank loan out, or something like that. Okay, it's all variations on theme. Okay, questions on this? Talked about it before. All right. All right, let's talk about inflation and price indexes, right? Like CPI. There are two price indexes we have to deal with, and the price indexes, what they do is they allow us to see what is happening to the value of the money over time, what is happening to inflation over time. The idea of inflation is that over a period of time, what happens to the prices?
They increase.
Prices go up, and therefore, what happens to the value of the money?
Goes down.
Goes down, right? The value of the money goes down because it doesn't have as much buying power when prices are higher. Okay, you will need to spend more dollars to buy the exact same stuff as what you did before. Okay, so the value of the money has decreased as time proceeds. And what is the opposite of deflation, by the way? Or excuse me, I just said it.
Inflation.
What's the opposite of inflation?
Usually.
Yeah, deflation, right? Which is when price levels go down and therefore the value of the money goes up. Okay, so when we're using price indexes, this is how we can measure what is happening to the value of the money over time. All right. And the two price indexes with which we are concerned are the CPI and the GDP deflator. Okay, what is CPI? What does that stand for?
Something price index?
Yeah, that was the Consumer Price Index, CPI. Okay, Consumer Price Index. And the idea with CPI, the Consumer Price Index, is this is measuring how inflation affects the average urban consumer. Okay? Because the way you figure out a price index is, you remember, you have to figure out what prices are happening to a certain set of goods. Right? The terminology that's used is a market basket of goods. So you have a set market basket of goods, and you compare what has happened to their prices over time. Okay? So CPI, you're looking at what is it that the average typical urban consumer tends to buy, and then you analyze that particular market basket every single month. Okay? So this is where I have the analogy of, all right, you're the Bureau of Labor Statistics, the BLS, they're the ones who compile this. They think of what the average urban consumer is going to buy. So they go down to Consumer Mart with their shopping cart, and they pile everything into their shopping cart that the average consumer is going to buy. Okay, and they look at what the prices are, and then they check out and see what the total is. They do it again next month, right? They go back to Consumer Mart with the same shopping cart. They put all the exact same things into the basket and see how it totals up that time, right? So they do this month after month. Well, if the total at the checkout is increasing from one month to the next, what does that mean?
CPI is going up?
Okay, well, that means, it's true, CPI is going up, yeah, but it means inflation. Alex, you gotta have a mask on. Right, that inflation is occurring because you have to use more money to buy the exact same goods we did before. Alex, mask. You have to use more dollars to buy the exact same stuff as what you did before. Okay, so the value of the actual items in the cart, that hasn't changed. What's changed is the value of the money. You have to use more money to buy the same stuff as we did previously. Okay. Now, when we're talking about a price index, this is just a way of standardizing it, right? So we're able to make comparisons from one period to the next. So, CPI, or any price index, right? I'm talking about CPI here, but this is gonna be the case for any price index, is equal to the market basket of the comparison year divided by the market basket in the base year times 100. Okay, so what is the market basket for comparison year versus the market basket in the base year? The base year is really whatever it is that you choose it to be, okay? So this is going to be the year against which you judge all the other years, okay? So let's say we're talking about 2015, that's our base year. Okay, so 2015 would be the year against which we judge all the other years, all right? So basically we're saying if 2015 is our base year, we're gonna value everything in 2015 dollars, all right? Everything will be adjusted to that, and we'll compare everything to 2015 dollars, okay? Now, typically, when you're going forward, not always, but typically when you're going forward in time, what's happened to the price index? It will get bigger or smaller?
Bigger.
Bigger. And typically, but not always, when you're going backwards in time, the price index will get
Small.
smaller, okay? Now, the price index in the base year is always what?
1 or 100.
100. Always, 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 the price index in the base year will be 100. The reason for that is the market basket in your comparison year, the numerator, well, that is your base year, okay? So we're talking about the market basket in 2015 divided by the market basket of 2015, it's the same number, right? So it'll be same number over same number, that's 1 times 100 gives you that, okay? So again, price index in the base year, always gonna be 100. How about this? Let's say, in 1 year the market basket is, I'll try to keep it relatively easy, especially since I'm trying to do math on the fly. Let's say in 1 year the market basket of goods is $1,000, and that's our base year, okay? The next year the market basket of goods costs $1,100. So in our comparison year, let's say it's 2016, the market basket was $1,100. And then in the base year, that market basket was $1,000. Yeah. So this is where we're trying to figure out the price index. We can figure that out fairly easily, right? Let's see. What's going to be 1,100 divided by 1,000?
1.1.
1.1. Right, times 100, so that gives you a price index of 110. Okay. Now what this means, that price index of 110, the reason we like to use these price indexes is we're able to standardize it fairly easily. Right, so here, these are relatively easy numbers, but you wind up having a market basket of $1,563 divided by a market basket of 922. Right? So you can use really complicated numbers. We're not going to do that to you on the test because again, you can't use calculators. So they're going to have stuff that's going to be more this style, stuff that's going to be relatively easy to figure out. Yeah. But we're standardizing it in such a way that what this means is that in the subsequent year, in 2016, you would have needed to use $110 to buy what would have only required $100 in 2015, okay? Now, if we want to figure out the inflation rate is the percent change from one price index to another, from 1 year to another. So if I was to ask you what is the inflation rate between 2016 and 2015, the answer would be
1.1.
percent change formula, right? You can eyeball it fairly easily here, but percent change formula is always the same. It's equal to the new number minus the old number divided by the old number times 100, just for put it into a percentage. Okay, and this is a percent change just for inflation rate. This is a percent change for anything, right? Talking about what was the percent increase in mass, something, right? It'd be the same thing. Okay, the new number minus the old number divided by the old number times 100. So in this case, the price index is 110. That's the new number. The old number was 100. Divided by the old number of 100 times 100. Yep. So you get 10 divided by 100. Right. You get 0.1 times 100, which gives you 10%. Yeah. So the inflation rate from 2015 to 2016 was 10%. Whoop. I don't have Gabe today. It's okay. We don't have it even video every time. Although David was saying that he was getting motion sickness watching your.
Who said?
Dan.
Oh, it was Dan.
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 Dan, my film.
Dan tried to shift the blame.
Yeah, Dan wasn't saying anything. Well, just blame Dave. David now. He just stayed quiet. He's like, yeah. we're not gonna-" Okay. So we'd say there was 10% inflation from one year to the next. Okay, and you could wind up having a number like, I don't know, 150 or something like that, right? All works out the same way. Okay, questions on this? Okay, so CPI is what is the typical average consumer is going to buy. GDP deflator, which is the other price index that might show up, is really just the same thing. It is a price index, but instead of looking at an isolated number of goods the typical consumer is going to buy, it's talking about everything. Okay, so it's called the GDP deflator because it is looking at the value of everything that is getting produced. Okay, instead of just a few things. And the GDP deflator is equal to nominal GDP over real GDP times 100. Okay, nominal GDP over real GDP times 100. And typically if you get a question involving this, it's solving for X. Okay, they'll give you 2 out of the 3 parts and they want you to find the other one. Okay, so if you just know the equation that the GDP deflator is equal to nominal GDP over real GDP, then you should be able to answer those questions. All right. The only thing you got to bear in mind is sometimes with CPI questions, what they'll do is they'll give you a goods and prices. All right, so you got to figure out what the market basket is before you can do the rest of the calculations. Okay, so it might be like, oh, in a particular country, they produce 5 widgets at $3 a piece. Okay, well, that's just 5 times 3 would give you a market basket of 15 at that point. See how that works, right? And we'll look at a couple of FRQs where they do that sort of thing so we can experiment with a little bit. All right, and then let's talk about trade. That's another big thing, right? So we got trade, where countries gonna be trading with each other. And we talked about trade barriers and stuff like that, right? That was in one of those videos. The big thing though is going to be the balance of payments. Okay. the balance of payments is the idea that you have money leaving and money coming back in via different routes. Okay, so this is where you have that double book entry thing, right? So you've got two accounts: the current account and what was the other one? Financial account. All right, current account and financial account. And what falls under the current account?
Is it goods and services?
Well, yes.
Is it the debit or credit
Well, yes. All right. Well, in both these accounts, right, the current account and the financial account, you've got credits and debits. You have credits in an account if there's money coming in via that account. Okay, and a debit is when money is leaving via that account, right? You always follow the money. Is the money coming in or out? If the money is coming in to the country, that goes towards that account. If money is going out of the country, then that's going to be a debit for that account. Okay? And the current account and the financial account have to equal each other. So what that means is that if one is going up, the other one must be going down by the same amount. Okay, so if one is moving towards surplus, the other is moving towards deficit, and vice versa. Okay, now what falls into the current account? First of all, you got balance of trade. Okay, and terminology here, balance of trade is under the current account. We're talking about balance of payments, we're talking about the current and financial account. Okay, so balance of trade, what we mean by that is imports and exports. Okay, that's just imports and exports, net exports. So if we're exporting goods, is that going to be a credit or a debit to the current account?
Credit.
Credit. Again, follow the money. If we're exporting goods, goods are leaving, where's the money going? In. Okay, so that'd be credit to the current account. And imports are debits to the current account. We're importing goods, money is leaving. Always follow the money. Okay. So we got that. We have income from foreign-owned assets. So if I own bonds from another country, or stocks from another country, or I own a factory or another country, or an Airbnb in another country, and I get income from any of those assets, that would be a credit to the current account. Because that is income I'm receiving from assets abroad that is coming into the country. Okay? So any kind of income from foreign assets is going to be under current account. And then finally, just net transfers. Okay, what I mean by that is just simple money movement. So if I've got family in Germany and I was to send them money, then that would be a debit to the US current account because I'm sending money elsewhere. Okay. Or if I decide to travel to Europe, then that would be a debit to the US current account because I'm taking my money elsewhere and spending it on souvenirs. Okay? Financial account is predominantly the purchase of real and real and financial foreign assets. So if I buy those stocks abroad, when I buy those stocks in some other country, that purchase would be a debit to the US financial account because money is leaving the US and going to another country to buy financial assets, I mean stocks. When I get income from those stocks, the income would fall into the current account. but the purchase of the stocks is under the financial account. Okay? And when I mean real assets, I mean like real estate. So if I buy that factory somewhere else, then that would be under the financial account. Debit for the US, credit for that other country. Okay? So if I buy houses or I buy that Airbnb, right, all that would be under the financial account. When I get income from those, that is under the current account. Okay? All right? And the reason that it works this way is that when money goes out one way, it's got to come back in another way, right? Because dollars are most usefully spent where? Well, what country takes US dollars? It turns out the US, right? Yeah, there are actually a couple of countries out there that use US dollars as their currency. They don't even bother with their own currency, they just use dollars, which has pluses and minuses to it. But generally speaking, they're best used in the US. So if money is leaving one route, dollars are leaving one route, let's say that we're running a trade deficit, which we do, which means we import more than we export. That means we have more dollars leaving than are coming in via trade. All right? So you have dollars that are being held by foreigners elsewhere in the world. Well, in order to be able to use those dollars most productively, they need to get back in the US, right? But how are they going to do that if they can't use it for trade? Okay, so they'll invest in real and financial assets. So you have money going out in the current account because of our trade deficit, and then you've got that money coming back in via the financial account, and where foreigners are going to be buying real and financial assets in the U.S., right? They can build factories or buy houses, or that'd be the real stuff, right? Or they can invest in U.S. financial assets. They can buy U.S. stocks, U.S. bonds, and put them in U.S. savings accounts, whatever, all right? So the money's going out here, and it needs to find a way back in somehow or another. If it can't find its way back in here, it'll find its way back in over there, okay? So this is why they have to balance, hypothetically, is the same amount of money that's leaving here will come back in there, right? Just a different avenue. This makes some sense? All right? So if one is moving towards surplus, the other one is moving towards deficit, and vice versa. Okay? Questions? You guys are being very quiet today.
It's the new people.
They've disrupted the
harmony.
Equilibrium.
the social situation. Oh, it's kind of funny. I've seen that before. Like even just like one person sometimes makes a difference. It's not a class. Huh? That was Izzy's fault.
100% Izzy's fault. None of anybody else's. Just Izzy.
I used to come in here, Kyle.
Yeah.
Yeah, it was still quiet.
While y'all were gone, we were actually kind of.
You're just less.
By the way, this is weird, but I was at Book Club Cafe on Saturday. There was like a clone of you who was one of the waitresses.
Really?
Yeah. I mean, they had a mask on, so maybe that helped. But there was a waitress that I mean, she was our waitress. Like that looks like Izzy. I was like waiting for you to introduce yourself, and it wasn't you. It was like, yeah, but it was weird.
Expectations averted.
Imagine.
Yeah.
What if I ignored you? That'd be so funny.
You're waiting.
You just made up a name. Okay, so let's talk a little bit about foreign exchange market also, right? Forex, foreign exchange market. This is the idea of currency trading, right? So if you go somewhere, you got to transfer your dollars into something else, convert it into something else. The idea of Forex is that determines how much money you're going to get for the other currency, okay? And how much you get is a matter of supply and demand. Okay, it's just like everything else. Supply and demand is determining the price of one currency compared to another one. It used to be a long time ago that everything was pegged to gold, right? So that was the easy conversion. So you knew how many dollars were worth an ounce of gold, and so you knew how many pounds were worth an ounce of gold, so you can convert based upon that. Okay. But that doesn't exist anymore, right? We use what's called a floating point exchange rate, which is how much is one currency worth compared to another one, and it's a matter of supply and demand. So this is where we have those two corresponding graphs. Okay, So each one of these is going to be a market for a different currency, right? But we're going to have the two currencies. So let's talk about yen and dollars. So this is the market for dollars on the foreign exchange market, and this is the market for yen on the foreign exchange market. Okay, quantity of dollars, quantity of yen. And what we have here on the y-axis is going to be yen to dollars. Okay, now just like in a supply and demand graph, this is price. That's really what that is. Okay, this is price. It just so happens that we are pricing dollars in terms of yen, right? How many yen does it take to make up a dollar? Yen to dollars. Okay, easy way to remember what goes on the denominator here is that if it's on the bottom here, it's on the bottom right there. Okay, so if we're talking about quantity of dollars, then dollar sign is going to be in the denominator on the y-axis. Okay, which means over here for quantity yen on the y-axis, it's going to be
Yen over dollars.
dollars over yen.
Or, yeah.
Bottom. Okay. So this is going to be the supply and demand for dollars on the foreign exchange market. This will be the supply and demand for yen on the foreign exchange market. Okay. So here, wherever the equilibrium is, that's going to be the price of dollars currently. Okay. So that's how many yen it takes to equal $1. So let's say, the United States, PS5s. So the PS5 is released. What do people want to buy? PS5, even though they can't find them, they want to buy them. Right? So we increase the purchasing of PS5s. Well, in order to buy this Japanese-produced electronic good, what do you need?
Money.
What kind of money?
Yen.
You need yen, right? If it's Japanese produced, you need to buy it in yen. And what you've got is dollars. So we need to convert dollars into yen. Okay? So what happens in our scenario here is, which one is more desirable to hold now? The dollars or the yen? The yen, right? And which one is less desirable to hold now? The dollars, all right? So the demand for yen is increasing, all right? Because that's what you're trying to buy, right? That's what you're trying to get is the yen. So the demand for yen is going to increase. And over here, what's happening to the supply of dollars?
Decreasing.
Not decreasing,
Oh.
increasing, all right? Because picture Forex as being an actual physical location, right? Like in an actual currency store. You walk in with some dollars, and what are you trying to do with those dollars? You're trying to sell them. You're trying to get rid of them. Did you just increase the supply of dollars in that store?
Yeah.
Yes, you did. Right? And you increase the demand for yen because that's what you're trying to buy. Just like any other product, right? So the supply of dollars on Forex increase, and you have a corresponding increase in demand for yen on the Forex. So what happened to the exchange rate? The exchange rate for dollars went down. And what happened to the exchange rate for yen? They went up. Okay?
Are any of the three responses going to be us like doing a graph? Like
Yes.
Okay.
Unless they're doing digital, and digital, since you can't upload anything, they won't ask you to do graphs, but there could be more complications doing it that way. Right, but if you're the paper and pencil, guaranteed they're going to ask you to draw graphs. Okay, that's why it's very important to know each one of the graphs. Right, I've talked about this, but they'll give you a point often just for drawing a graph correctly. You can get everything else wrong, but you can at least get a point for your drawing skills. All right, which means drawing it correctly and correctly labeling it in all the places. So in this case, the exchange rate for the dollar decreased. What do we call that? Starts with D.
Inflation?
Depreciation. Okay, depreciation is referring to currency value. So depreciation is when the currency lowered in value, the exchange rate decreased. All right? When the exchange rate decreased, what we're saying here is that you need fewer yen to equal $1 than before. Let's say before you needed 100 yen to equal $1, now you only need 95 yen to equal $1. All right? Well, that means the dollar became weaker, it depreciated. All right? And then over here, the exchange rate for the yen increased, and we call that appreciation. The yen appreciated, it became stronger. Right? You need more dollars to equal a yen than what you did previously. Okay, so when you're comparing these two currencies, if one is becoming weaker, the other is becoming stronger. Necessarily, it has to work that way, right? You're talking about relative to each other, so if one is going down relative to the other one, that means relatively the other one's going up, right? One becomes weaker, one becomes stronger. Now, what this also means is, well, if a currency is weaker, what does that do to exports for that country? If the dollar becomes weaker, what will that do to U.S. exports?
They're gonna
Lower 'em?
Export less?
They'll export more. Why?
People
they
will
want
buy more.
different.
Okay, well, a cheaper dollar, less valuable dollar, means U.S. goods become comparatively cheaper for other countries than what they were before. Okay? So therefore, we will export more. However, the weaker dollar means that we will import less. Right? We're going to import less because the dollar is stronger compared to, say, the yen, and therefore doesn't have as much buying power. Okay? So we export more, import less. That's what a weaker currency will do. And then over here, if the currency becomes stronger, it goes the other direction. A stronger currency means, what can we do?
Import more and export less.
Yeah, we can import more because a stronger currency means we buy more of the other person's stuff. Okay? And a stronger currency, however, means our stuff becomes comparatively more expensive, so therefore we will export less. All right? So which one's better? Stronger currency, weaker currency? Depends on what you're trying to do. Okay? Now, things that can affect exchange rates, right? You can have interest rates that will affect exchange rates. Because if you're an investor, you want to save your money, what do you want? More money, right? So if interest rates are higher in another country, you can save your money in one country or another one. You want to save your money where the interest rates are higher, right? So if interest rates are higher in Japan, I want to save my money there. What will that do to the demand for yen?
You're making it go up.
It'll make it increase, okay? And the supply of dollars would increase. So the yen would increase in value, right? Appreciate, the dollar would depreciate, right? Or let's say that the economy is booming in the U.S. and it's not as good in Japan. Well, what's going to happen then? If the economy is booming in the U.S., what do Americans have a lot of? Money. And what do we want to do with our money? Buy stuff, spend it, including on Japanese goods. So the supply of dollars, again, would increase. The demand for yen would increase. Okay, dollar would depreciate, yen would appreciate. All right. So there's one factor I think I'm missing. Can't think of it right at the moment. Okay, questions on this? Yes, no? Feeling okay? You want to look at an FRQ and work our way through that guy?
Yeah.
All right. All right, I'm going to stop this here for the video, and then I'll just start a new one for the FRQ.